Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 2 Theory. For the session of October-November 2024, we have the subject code 5054 and the variant of this paper is 21. We have 1 hour 45 minutes for this paper. An important instruction is that we have to use the value of small g, that is equal to 9.8 meter per second square. This paper is carrying 80 marks. So we're going to start our question paper from question number 1. Question number 1 say that a trolley of mass 0.2 kg is at rest on a frictionless surface. A block of wood is attached to the trolley. The volume of the block of the wood is 0.0012 meter cube and the density of the wood is 650 kilogram per meter cube. Calculate the combined mass of the trolley and the block. Okay, so first we're gonna we have been given the mass of the trolley. So first we have to find the mass from these value, the mass of the wood, or mass of the block. How we're gonna find? We know the formula for the density, that is equal to density is equal to mass and over volume. Then the mass as the formula, that is equal to density into volume. The density is given in this question is 650 for the wood and volume is given 0.0012. So after multiplication this we get the answer, that is equal to 0.78 kg. So the total mass would be, by adding the mass of the trolley and the mass of the block we just have calculated. So after adding those value we get the answer 0.98 kg. So this is the combined mass. Okay, kilogram. Figure B part. Figure 1.1 shows that a student attaches a spring constant 14 Newton per meter to the front of the trolley. Okay, the student holds the trolley and block and stretches the spring. He releases the trolley and block. The trolley and the block accelerates from the rest. As the trolley and the block accelerate, the student keeps the extension of the spring at 0.035 meter. Calculate the force exerted on the trolley. So we know that the force and the kx, so k is the spring constant, force f is force and x is the extension in the spring. So we know we have been given that spring constant at the start of the question, that is equal to 14. So we're gonna use this 14 and the extension of the spring is also given, that is 0.035. We just need to multiply to get the answer, that is equal to 0.49 Newton. Okay, mostly students do not memorize this formula, so they would be confused how to calculate the force in that case. So you need to know this formula, F is equal to kx. Okay, moving to the next part, the trolley and the block are pulled a distance of 0.86 meter by the spring. Calculate the work done in the trolley. So the formula for the work done is W is equal to force into distance, and we know that 0.49 is the force we just calculated in the previous part, and the distance is given for this part, that is equal to 0.86. You just need to multiply to get easy 2 marks for this question, 0.42 joule. So this was a very easy part. Moving to the next part. Next part is theoretical. Explain why the power transferred to the trolley and the block releases as the speed increases. Okay, transfer to trolley and the block increases as the speed increases. As we know that when the speed increases, it means the objects accelerate, and when objects accelerate, work is done, and the work is done is greater the amount. So we can say that due to increase in the energy, the power is transferred to the trolley. So how we're gonna write that? As the speed increases, acceleration, force and work done also increase, because the change in speed is increased. So acceleration and force is also increased, and due to it work also done increase. So due to the increase in the work, energy of the power is transferred to the trolley. So that's why trolley start to keep moving. So that's one easy. I think enough explanation for the 2 mark. Okay, moving to question number 2. A student makes a ball from modeling clay. Okay, the ball has a mass of 0.2 kg. Okay, she drops the ball from the height of 40 meter above the ground. Calculate the initial gravitational potential energy. We know that this is the simple question. Potential energy is equal to mgh, and the value of mass is given, that is 0.2, and the value of g is 9.8, which is written in the instruction, and 40 is the height, so we have to just multiply to get the answer, that is equal to 78 joules. So we're gonna write our answer in answer space, that is equal to 78 joule. Moving to its next part is that calculate the speed of the ball immediately before the ball hits the ground. Ignore the effect of the air resistance. So we need to calculate the formula. We have to derive the formula. Calculate the speed of the ball immediately before it hits the ground. So it means that kinetic energy and potential energy both would be equal. So we have to apply this formula, half mv square is equal to mgh, where we're gonna cancel m with m, and v square is equal to 2gh. Now you need to take the square root, that it would be equal to v is equal to square root 2gh. Now the value of g is given, that is 9.8. Value of height is also given, that is given in the earlier part that we use, that is 40. So after taking the square root, we get the value, that is equal to 28 meter per second. So this was an easy question. Next part is from the topic of heat capacity. When the ball hits the ground, it stops moving. The kinetic energy of the ball is transferred to internal energy. The temperature of the ball increases. The specific heat capacity of modeling clay is 1400 joule per kilogram degrees Celsius. Calculate the maximum possible temperature increase of the ball. Show your working temperature increase. Okay. We know that the formula for the energy is equal to E is equal to mc delta theta, or you can take this as q. Delta theta show the change in temperature, and just we have to calculate this. Delta theta would be equal to mc over E. If we look at delta theta would be equal to E over mc, so it would be E over mc. The value of E is given, that is, we just calculated in the previous part, that is 78. In the first part we calculated the gravitational potential energy, that is equal to 78, so we're going to use this. And the value of mass is given, that is equal to 0.2, and this is also given at the start of the question. And the value of heat capacity is 1400. So after this we have to apply this formula. We get the answer 0.828 degrees Celsius. So this would be our answer, 0.28 degrees Celsius. Moving to the next part, suggest one reason why the actual temperature increase of the ball may be smaller than the value calculated in B first part. Okay. The question is asking why the actual temperature increase of the ball may be smaller than this. Is because the some thermal energy is transferred to the ground due to air resistance, due to friction, so that's why energy is being lost. So the actual increase in temperature would be can be smaller than this, because in the real world there is no inelastic movement. All those movements are inelastic, and due to friction the energy is being lost, so the actual temperature would be less than calculated in theory based. Okay, so this is how we're gonna write our answer. Page number 5 is blank. Moving to question number 6. Question number 6 is that figures 3.1 show at a room temperature the gas is trapped in a metal cylinder by a metal piston fixed in position. The metal cylinder is immersed in the boiling water and the temperature of the trapped gas is increases. Explain in terms of electrons and atoms of the metal how metal energy is transferred through the walls of the metal cylinder. We know that the particles will vibrate more. Why particles? Because when they are in the hot container, in the boiling water, the temperature would increase, so the particles would have more energy, they will vibrate more, so they will transfer their energy to the free electron because inside it there is a metal cylinder. And free electrons will move through a metal, collide with neighboring moving electrons, so energy is being transferred. So this is how the energy is being transferred. So you're gonna write that the particles will vibrate more due to the gain in temperature. Free electrons move through a metal, collide with neighboring moving electrons, so energy is being transferred. This was a very simple explanation. Moving to its D part, the piston is fixed in the position, so the pressure of the gas increases as the temperature of the gas increases. State what happens to the motion of the particles of the gas as the temperature increases. We know that due to the increase in temperature, the particles gain energy and vibrate more and they will collide more. Okay, so this is a simple 1 mark explanation. Moving to second part, explain in terms of particles of the gas why the pressure of the gas exerted on the walls of the metal cylinder increases as the temperature increases. First, we need to know what is the pressure of the gas. Pressure of the gas is the particles colliding with each other or walls of the container in which the gas is being kept. So we're going to write that the particles collide with each other and the walls of the container. The particles exert greater force and the chances of the collision will also increase when the temperature increases, because due to the increase in the temperature they have more energy to vibrate, so the chances of collision would increase, so that's the pressure would also increase. Moving to C part. C part is that the gas in the cylinder reaches at a temperature of 100 degrees Celsius. The piston is released and moves to the right. The temperature remains at 100 degrees Celsius. The pressure of the gas now decreases. Explain in terms of the particles of the gas why the pressure of the gas now decreases. Okay, the gas of the cylinder reaches at 100 degrees. The piston is now released. Why? When the piston is released, it means that its volume is being increased. Its volume is being increased means the particles have more space, so their chances of collision will decrease. So then the chances of the collision will decrease, the pressure will automatically be decreased. So we can write that the particles are further apart, so fewer collision in per unit time. Moving to next part. Eventually the piston stops moving. Explain why. The pressure inside becomes equal to the outside pressure, that is atmospheric pressure, so there is no net force or resultant forces acting on it, so that's why piston stop moving. So I'm going to repeat that the pressure inside becomes equal to the atmospheric pressure and no resultant force acts on it, so piston stops moving. Okay, moving to question number 4. Question number 4 is a very good practice for the topic of dispersion of light. A student directs a beam of white light from a filament lamp towards the glass prism in a dark room. Figure 4.1 shows the beam of white light incident on the left hand side of the glass prism. You can see that beam of white light that is dispersed, that is refracted and dispersed into R is for red and V is for violet. Now these blue lines are not drawn, these are drawn for the first part. A screen is placed on the right of the glass of the prism. Red light is observed at a point R and V is given on the observed at point violet light. Draw on figure 4.1 to show that the path of the red light and the violet light between the left hand side of the prism and the screen at point R and point V. We can see that these are being refracted, so we have to draw these arrows and they are entering from rare medium to denser medium and then from denser to rarer medium. So that's why you have to draw such type of pattern over here to show the ray diagram, and this is carrying 2 marks. Next part, state what these observations show about the change in the speed of the red light and change in the speed of violet light as each enters the glass from the air. We know that both red light and violet light speed will decrease because they are entering into the denser medium, so speeds will increase as they enter from the glass from the air. However, red light has some more speed than violet light, so that's why it is bending less, so it has more speed compared to violet light. So we're gonna write to get these 2 points to get 2 marks. Moving to C part, 5 other colors of light appear on the space screen between the red light at R and B. It means R and B. Red is the first and B is the violet, and you need to write the all other state the name of the 5 colors and list them in correct order from red to violet. So red, then orange, yellow, green, blue, indigo, and violet. Show next part, state how the frequency and the wavelength of the color light change during from red light to violet light. We know that frequency and the wavelength of the color light will change from red light to violet because frequency start to increase and wavelength start to decrease. Okay, on figure 4.1, point P is shown immediately next to R. This is in no light is observed at point P, but a detector at point P gives radiation reaching the state which region the electromagnetic spectrum is being. So from the above the visible there is the infrared region, so we're gonna write that infrared. So this is the simple question from the topic of the spectrum. Moving to question number 5, that is from the topic of ultrasound. Is a longitudinal wave. Ultrasound are those who have the value that have greater frequency than 20,000 Hz, which cannot be heard by human ear. Human ear audible range is 20 Hz to 20,000 Hz is too high. Ultrasound waves cannot travel in the vacuum. Yes, they are the longitudinal wave, that's why they cannot travel in the vacuum. So you're going to write that longitudinal wave depend upon the medium, that's why ultrasound waves cannot travel in a vacuum. So in vacuum there is no medium. Okay, part B, describe how a longitudinal wave differs from a transfer wave. In longitudinal wave, particles vibrate parallel to the propagation direction, and transverse wave particles are perpendicular to the propagation direction. In longitudinal they are parallel, and in transverse wave the particles are perpendicular. Okay, moving to its next part, our ultrasound transmitter has used for medical scan produce an ultrasound wave of frequency 8.4 megahertz. In a soft human tissue, ultrasound travel at 1500 meter per second. Calculate the wavelength of the ultrasound in human tissue. So we have to apply this, the formula, that is V is equal to F lambda. Over here we have to calculate the value for the lambda, that is equal to V by F. What is the value of V? We know that value of V is 1500, and what is the value of frequency that is given 8.4. So what is mega? Mega means 10 raised to power 6. So you need to know the prefixes. Examiner do tend to ask about the prefixes. 1.8 into 10 raised to power minus 4 meter. This would be your final answer for this question. Moving to next part, the ultrasound waves passes from the soft tissue into the bone, and where the speed of the ultrasound wave is greater than 1500 meter per second. State what happens to the frequency and to the wavelength of the ultrasound wave as it passes into the bone. We know that frequency does not change and wavelength increases. So that's why frequency does not change and wavelength increases. That's why speed is being constant. Okay. Moving to question number 6. Question number 6 is from the topic of magnetism. A bar magnet can rotate freely around a thin rod through the center. The bar magnet is at rest on a frictionless horizontal surface in a laboratory which is shielded from the Earth's magnetic field. State a substance from which the bar magnet could be made. It is, you can write steel in the answer space. Moving to its next part, the thin rod is perpendicular to the top of and bottom of the surface of the bar magnet. Figure 6.4 one shows a view from the above of the bar magnet with north pole, the south pole, and thin red. Draw on figure 6.1 to show the pattern and the direction of the magnetic field around the bar. We know that from north it will originate and it will end on the south, and you can draw only two lines, or you can draw as many lines as you want, and you can show it like that. By drawing these two patterns you get the 2 marks. By also showing the arrow you get the full 3 marks. If you do not plot the arrows, you will not be given full marks, and if you plot wrong arrow direction, your marks will be deducted as well. Moving to its C part, an electromagnet is switched on and a strong magnetic field is created around a bar magnet. Figure 6.2 show that the direction of the strong magnetic field due to the electromagnet is from left to right across the page. Magnetic field line due to electromagnet. Okay. First part is draw arrows on figure 6.2 to show the direction of the horizontal force that acts on the poles of the bar magnet. We know that these forces would be parallel to this direction of the magnetic field, but they would be opposite in the direction, so they would make a torque or couple. That's when this magnet will start to rotate or move. So we have to draw this arrow at the north, and we have to draw the arrow at south. Both will indicate the horizontal direction, but in opposite direction, parallel to the horizontal direction. Moving to next part, describe and explain what happens to the bar magnet when the electromagnet is switched on. The bar magnet will experience a force and it become an electromagnet due to the interaction between its field and the external field, and when the both fields intersect, the force is produced. Okay, it will produce a couple and moment, like in this case and magnet will rotate until it finishes parallel to the field line. So it will moving after it finishes. When it finishes parallel to the lines, then it will remain parallel because the direction is being same. Okay, moving to question number 7. Question number 7 is from the topic of electricity. A filament lamp connected to a 12-volt power supply transfer 24 watt of power. Calculate the current in the lamp. We know the formula for the power, that is equal to P is equal to VI, and we need to calculate the current, that is I is equal to P by V. What is the value of P? That is equal to 24. What is the value of V? That is 12. So we get the value that is equal to 2 ampere. So this would be our answer. Moving to a second part, the resistance of the lamp in the circuit. We have to calculate the resistance. We know that Ohm's law had the formula V is equal to IR. So we have to apply to get the answer, and R would be equal to V by I. What is V? That is given at the start, that is 12, and we have calculated I in the previous part, that is 2. So 12 by 2 we get the answer, that is equal to 6 ohm. So you're gonna write your answer 6 ohm in your space. Moving to its B parts. A student has a battery of EMF 12 volt. The student uses the battery in the circuit with the 12 volt filament lamp to obtain a range of suitable readings and plot the current voltage graph of the lamp. Okay, figure 7.1 show the battery and the filament lamp. This is figure 7.1. This is the figure is showing only this part and this part. On figure 7.1, complete the circuit diagram to suitable for circuit. You will need to add additional components. So I have added a variable resistor. I have added ammeter to measure the value of the current, and ammeter is added on series, and voltmeter is added in parallel. So these are the 3 components that I have added, and I have attached in them like that. So this is how you get the 2 marks. Okay, moving to next part. On figure 7.2, draw the shape of the current voltage graph for the filament lamp. So it should be like Ohm's law. Initially the current and the voltage will be directly proportional, but after some time when the current start to increase, the temperature start to increase, and its effect would be applying the potential difference. The energy is being lost due to the resistance, so current will not be produced in the same way. So we will plot the graph in term of decreasing gradient. So this would be like that. Okay, now I will move to the next part. State what happens to the resistance of a filament lamp as the applied voltage increases, and explain one reason for this happening. Resistance of a filament lamp increases as the temperature increases. Particle vibrate more vigorously, so that's why opposition of flow of charges increases. That's why the value of current would decrease. So this would be your explanation. Moving to question number 8. Question number 8 is from the topic of radioactivity, and this is a very good question to practice. The nuclear notation for the radioactive isotopes hydrogen 3 is H31. Explain why hydrogen 3 cannot decay by the emission of alpha particle, because alpha particles should have 2 neutrons and 2 protons, but it is containing only 2 neutrons and 1 proton, so that's why alpha particle cannot be emitted through this decay. So we can write that because it contains only 2 neutrons and 1 proton, compared to alpha particle that have 2 neutrons and 2 protons, so that's why they cannot emit alpha particle. Okay, moving to its next part. Hydrogen 3 decay by the emission of beta particles to an isotope of a different element. This element is represented in the equation by Q. Complete the nucleotide equation for the decay of the hydrogen 3. This is very important. We have to build the nucleotide notation. So first we need to know that what would be the beta particle. Beta particles should have the electrons, so -1 would be their charge, and we would apply over here, it would be 0. So what would be the Q over here? Q would over here 3 plus 0, so it should balance, so 0 plus 3 should be 0. And what should be over here to get the value of 1? So it should be over here is 2, so 2 minus 1 would be 1. State the name of the element that is represented by Q. The name of the element that is represented by Q is helium. Next part is the half-life of hydrogen 3 is 12 years. Define half-life. Okay, we know that half-life is the half of the time of the total, so we can write the time required for the quantity of a substance to reduce or decay to half of its initial values, so this is known as half-life. Okay, next part is a sample of hydrogen 3 is placed on a laboratory bench next to the Geiger-Müller tube and counted. The count rate is recorded at the same time on a 4 consecutive days. Table 8.1 show the count rates obtained. We can see that day 1 has 92, day 2 count rate is 89, day 3 is 93, and day 4 is 81. State why the count rate decreases and increases. Over here we can write it decreases, over here it is increasing, and then it is also decreasing. Because it is a spontaneous nature of the decay, or it is a random nature of the decay, we cannot predict that it would increase or it would decrease. So it's a spontaneous occurrence of increase or decrease, so you can't predict. Okay, moving to last question of this paper, that is from the topic of the space physics, that is a stable star in a distant galaxy has a mass that is more than 15 times the mass of the sun, so it is a very big star. State the name of the nuclear reaction that occurs at the center of the star and describe the nuclear. So the name of the reaction is fusion, and you need to define it. In this reaction, 2 or more hydrogen nuclei join to form a large nuclei of helium. So this would be your answer, and this 1 mark for identifying the reaction, that is nuclear fusion, and 2 marks for its correct definition. In the next part, explain why this nuclear reaction helped to keep the star stable. Because it transfers a lot of thermal energy, so it will emit the lot of energy, and it produces a high pressure. Inward gravitation force would keep it balanced, so outward and inward would keep that planet would balance. Okay, so that star would be stable or balanced, not the planet. Okay, moving to its B part. As a massive star approaches the end of its life, it stops being stable and becomes a red supergiant. State why the nuclear reaction can no longer keep the star stable. Okay. We know that hydrogen will be completely consumed, or hydrogen will be run out, so it cannot be kept longer. So that's why nuclear reaction can no longer keep the star stable, so it will decrease and ultimately it will change into the black hole. In the next part, we have to describe that. You need to write that answer in your notes and prepare. This is carrying 3 marks, and you need to memorize this sequence, how this system works. Describe what then happens to the red supergiant. Red supergiant will explodes, turns into a supernova, produces heavy elements from a nebula, leaves behind a black hole. So you need to memorize that sequence. So red giant will explode, turns into a supernova, produces heavy elements from a nebula, leaves behind a black hole. So this is how we have completed our question paper. Thank you so much for watching this video and channel. Keep supporting. I will upload this video just before I'm solving just before the Sari, so you could the students who have mock exam tomorrow in the morning could practice after Sari. So best wishes for them. So keep practicing and keep supporting our channel and course, and best wishes for your upcoming exam. Thank you so much, and if you still have queries related to this paper, you can ask in the comment section. Allah Hafiz.